All right, hello again. So today, before I start today, a big shout out to Mr. Andrew Duncan, who has inspired me to do this flip classroom videos. So, Mr. Duncan, this is a big thank you to you. Okay, let's move on to linear modeling today. Linear modeling is as we have done before. So it's basically those problem solving kind of questions where we apply our linear function knowledge to a context. So it is just a way of describing the relationship between any two variables. So remember when we were doing the word problems and we had to let someone's age be X and let someone else's age be Y and something like that. So if you think back to a couple of weeks ago, that's when we started doing linear modeling, but we didn't give a name. So we're giving a fancy name now, which is linear modeling. So it's just basically using a function, using a linear function to describe the relationship between two variables. And as we've been graphing on the X and Y axis, so it shows us that the two variables are X and Y. The only difference is now is that we're going to give X and Y a name. So it could be the rate at which someone is traveling over a certain amount of time, or it could be the amount of money that someone's earning over so many days, or it could be the amount of time that it takes for someone to finish a job. So see, two variables, amount of time, finish a job, amount of money someone's earning based on how long they've been working. So two variables. And what we're going to learn today is how do we apply that to a context? How do we come up with a function, with an equation, and then how to graph it? Now, we're going to go a little bit further and have a look at two different scenarios so that we see if there's any point where the two functions are intersecting or where there's any similarity between two functions. Now, if we have two functions, so think back to when we did perpendicular and parallel lines. If there are two lines which are parallel to each other, what's common? Yes, their gradient. Okay, so we're going to look at whether there are if there is an intersection between two functions, between two lines, and what does that intersection indicate. Now, it's important to understand that for linear models, usually only the positive quadrant is used. So when I say positive quadrant, I mean, when we plot a graph, we only are using the plus X and the plus Y. So we're not looking down there and we're not looking down there. So what you can focus on is only the positive sides of the quadrant. Now the key elements are, and these are the key elements, so these basically it's the steps. So you first find the rule that links the two variables. So what is the rule? And it could be as simple as the amount of money that I earn is based on how many hours I work. And then you have sketch a graph. Then you use the graph or the rule to predict or estimate what the value of one variable is given the other one. So if I tell you that I work for 4 hours and my hourly rate is $50, how much would I earn for 4 hours? So, and then you also find the rate of change, which means that as one variable is increasing or decreasing, what is happening if one variable is increasing, what is happening to the other variable. Okay, now let's have a look at an example. For this example, we are going to look at two different scenarios. So two scenarios, and we're going to see if there's a relationship between the two. Now, sales rep Peter earns $400 per week, plus $20 for every sales he makes. So if I have to write that as an earning or as a wage, as an equation, so this is for Peter. Okay, his wages, he earns $400 per week, so $400 plus $20 for every sales that he makes. So plus $20 for every sales that he makes. Make sense? Why did I write 400 first? Yep, so that I could write it in the form of y equals mx plus c. Okay, now another rep, Mandy. So Mandy, this is for Mandy. She earns $200 per week. Oopsies, not that. We need to write that later. So she earns $200 per week plus $40 for every sale she makes. Okay, again, in the form of y equals mx plus c. Okay, so A says write a rule which gives the total weekly wage for each of the sales reps, which we've done. So this is A done already. Okay, draw a graph of W versus X using 0, or X greater than equal to 0 and less than equal to 40. So that is telling us that we have to draw in a positive quadrant. Now, if we have to draw a graph, what is an easy way of drawing a graph? What is one easy way that you can draw a graph? You can use table of values. We've learned so many different things. Yep. The easiest way is use our x and y coordinates. So let's use our x and y coordinates. Okay, which is using the x and y intercepts. So let's do that. So let's use our x and y intercepts. Okay, if we use our x and y intercepts, we have to make, so B, to draw a graph. For Peter, to find your y-intercept, you make x equals 0. So therefore what you get is W is equal to 20. So let's put that as x plus 400. So that is equal to 0. So therefore W is equal to 400. I'm going to use the intercept method to do A, to do for Peter, and another method to do for Mandy. Okay, to find our x-intercept, you make y equals 0. Okay, so if you make y equals 0, over there y corresponds to W. If you have a look, corresponds to W. So 0 is equal to 20s plus 400. Then we take away 400 both sides, take away 400 both sides, and that gives us 20s is equal to negative 400. And then we divide by 20, and then we get s is equal to negative 2. No, not negative 2, sorry. Negative 20. Okay, for Mandy, do we have to use the x-intercept and y-intercept method? Not really, because what we can see from there, C is equal to 200. And then how do you find the x-intercept? Yes, you can use this. You can make y equal 0, or we know that the gradient over there is 40. So when we draw our graph, I'm going to use that. Okay, that is our S, it's the number of, and that is our W, that's for our wage. Okay, and if you have a look at our graph, so M is equal to 40, which is same as 40 over 1. If we start at 0, so let's say that's 50, 100, so let's say that's 50, 100, 150, 200, 250. So we start at 200, which is our y-intercept. We go up, so this is rise, and this is run. So we go up 40 places, which is somewhere there. That's 50, so 40 would be there. And then we go 1 place. So 1 is very, let's see, our S, we want to go up to 40. So let's say 10, 20, 30, 10, 20, 30, 40. So 1 is like very little over here. Doesn't give a lot of room for us to work with, but let's just estimate it to be somewhere there. Okay, and then we draw a line. Now, what I have done already is, so we've got a line over here already. Okay, so if you have a look at our graph, let's have a look at our graph. Okay, and let's have a look at that point. So the orange line is for Peter, and he makes $400, which is over there, and his annual, and then on top of the $400, $20 per sales. Okay, and the purple one is for Mandy, who makes $200. So see how it intersects at $200, and she makes $40 for every sale. Okay, now let's have a look at that point. What is that point? That's the point where they intersect. That's the point where they intersect. So what does that tell us? If you have a look at the two graphs, what does that tell us? Which one has a more? So if you have a look, this is orange is Peter, purple is Mandy. Peter is a gradual increase. Mandy is a more rapid increase. So up to that point, maybe up to that point, who is earning more, Peter or Mandy? Yes, Peter. But then after that point, which is at 10, so after making 10 sales, Mandy is actually picked up. So Mandy is making more than what Peter is. You see that? So at that point. So what I'd like you to do is have a look at the two graphs, and from the graph what we can do is work out how many sales is needed for each one, by each one, to earn a certain amount of money. We can also work out that if Peter and Mandy, both of them, if they do 50 sales, how much money would they earn? So that's 50. Okay, if we go up, so if we go up 50, from 50 we go up, right up to until we intersected, we reach the graph. So this is Peter's graph. For 50 sales, Peter makes $1,400. Okay? But Mandy, for 50 sales, if we keep going, Mandy's is over here. So Mandy makes $2,200 for 50 sales. So see how it helps us to compare? Now I'm going to snip that and put it on our page later. Let's go back to our page. All right, so let's look at the questions now. Okay, it's going to come. So, okay, there you go. C. How much do each sales reps earn in a week when they make 12 sales? Now, we didn't look at 12 sales. We looked at 10 sales. Okay, so but even for 12 sales, we can work out. For 10 sales, we had a look on the graph. But how about for 12 sales? So, to work that out, you actually can use the formula. We can use the equation. So, So, part B. So, for Peter, his wages is equal to 20S plus 400. If he does 12 sales, it's 20 times 12 plus 400. Which gives us $240 plus 400, and that is equal to $640. Okay, for Mandy, for her wage, it is 40 times S plus 200. So she does 12 sales, 40 times 12 plus 200, which is $480 plus 200. And that gives us $680. So Mandy is earning more for 12 sales. But once it's less than 12, so if we have a look at this again, okay, that's for 10 sales. But if it's less than 12, then Mandy would be earning less than Peter. Okay? Now, question D. When do both sales reps have the same earnings? And as we looked at the graph, both of them have the same earnings when they have 10 sales. So if you have a look, we might make that bigger. If you have a look over there, okay, that corresponds to, oh no, it's not, oh yeah, it is 10. That's when they do 10 sales. Both of them have the same amount of earning, which is $600. And the next question. Okay, that's it.